Okay, so the table shows some quantities which row gives the correct order of magnitude. Mass of a coin. Mass of coin that small? I don't think so. Thickness of a sheet of paper. 0.01 meter, which is 1 centimeter. No. Weight of an apple. 1 Newton. How could it be 1 Newton? All right. Temperature of person's body. 10 Kelvin. 10 Kelvin will be basically 263 degrees Celsius. That's wrong. So weight of the apple we can. I think this is the only right answer, but 1 Newton is the weight of the apple. Let me think about it. 1 Newton means that 0.1 kg. Yeah. Apple could be 100 grams, so that's fine. Okay. A byte comprises of 8 bits. How many bits are there in 1 terabyte? So 1 terabyte is 1 into 10 raised to power 12. So multiply by 8 bits. So 8 into 10 raised to power 12. I think it should be this time. Pretty simple. Which pair of quantities contain both a scalar and a vector? These are both vectors. That's wrong. Charge and resistance. Both scalars. Both scalars. Temperature and velocity are scalar vector. 3T. Now, a transmitter emits a pulse of electromagnetic towards the reflector. Okay, fine. A pulse takes 6.3 microseconds to travel and reflect. So basically, you can see this is the time that it travels, and then it is detected again, like this, right? So what is the time-based setting? So I told you time period has to be equal to time base times the wavelength. So time period is 6.3 into 10 raised to power. So it goes and then it comes back. So detected once and twice. Okay. 6 into 10 raised to power minus 6. Time base we got to find, and the wavelength is 3 centimeters. Okay. So let's try to do it. So this is 2.1. 1, 2, 3, 4, 5, 6. 2.1 10 raised to minus 6. So, all right. So this is from going and backwards, right? Now it says what the pulse takes this to travel from transmitter to reflector. So it means that this was the reflector. So it takes like 2.1 times 10 raised to minus 6. So we should multiply it by 2, because then it will give us, the whole. So 4.2 microseconds per centimeter. That should be C. All right. Next, the micrometer is used to measure the diameter of two cylinders. The difference in diameter is calculated. What is the uncertainty in the difference? So, right. So we want to take the difference in diameter. So difference would be 16.24 minus 12.78. So this should be 16.24 minus 12.78. So 3.46, right? Oh, this is just uncertainty. Oopsie. That is not fair. Uncertainty is always added. So diameter. So whether you take difference or you take this, uncertainty is added up. So this has to be 5 millimeter. It has to be 5. D. Okay. Now the stone is thrown. Please do let me know when you want me to, explain something. A stone is thrown horizontally from the top of the cliff and falls into sea below. The air resistance negligible, path is shown. In which direction does the resultant force on the stone acts during its fall? Resultant force always acts vertically downwards, because when something falls, the only force it feels is either weight or a resistance. So it has to be like this, and weight is always greater unless it reaches constant velocity. Now, a car moves with uniform acceleration along a straight road. Oil leaks from the car at the rate of every drop 2 seconds. One drop in 2 seconds. Okay. The diagram shows the distance between successive oil drops. What is the acceleration of the car? Right. So if it dropped here, and suppose its velocity was u, so after 2 seconds, it would drop here. So let's call this v1. Right. Now, if its velocity was this, and after like 2 and 4 seconds, this was v2. Okay, fine. So what is the acceleration? Would this be 4 seconds? That be 2. That's tough actually. So let me make 2 equations. SUV80 9 U V is V1. Acceleration is 9.0. Oh, acceleration is what we need to find, and time is 2 seconds. So we have so many unknowns, right? So what we're going to do is I'm going to use S equals to UT plus half AT square. So it eliminate something. This will be 9, U will be U, time will be 2. This will be half, this will be A, and this will be 2 squares. So ultimately I'm going to get 9 2U plus 2A. Right. So let's call this first equation. Okay. Then I'm going to make SUV80 again. The reason I chose the starting point every time this, because I want one quantity to be the same. So the displacement is now 9 plus 12 is 21. Yeah. 21 meters. U is U. This is V2. Acceleration is A, and time is now 4 seconds. Now I know that I don't want to use this V2 because I don't know, it is not the same from the previous equation. So I'm going to use S equals to UT plus half AT square. And then I'm going to write 21. This is going to be U. This is going to be 4 plus half A and 4 square. Now 21 4U is equal to 16, 8A. Now this is my second equation. Now I want to replace. Now What I ideally want to do is whatever you want to find, right? You have to replace, you don't have to replace that, you have to substitute that. For example, I want to replace u here. So what I'm going to do is I'm going to make 9 minus 2a over 2, and I'm going to write it as u, and then I'm going to substitute it right here. So 21 equals to 4, 9 minus 2a over over 2, and plus 8. Right. Now I'm going to solve this. So 2 and 4 cancels out, so it is going to be 21. 2 times 9 minus 2a plus 8. 21, 18 minus 4 plus 8. 18 minus 21 is 3. 4 minus 8 is 4a, and a will be 3 by 4a. 3 by 4 meters per second square, which I believe has to be a. All right, is it clear? Anybody has a question, please let me know. So let me tell you this idea, right? Whenever a question comes that asks you something that has too many unknowns, so please make sure you take one common point between two, and that will help you, and then make two equations. Okay, the person of mass 60 kg stands on accurate bathroom scales placed on the floor of an elevator lift which operates in tall building. At a certain instant, the bathroom scale reads 58. Which row could describe the person directional movement, right? Now, remember when a lift is moving, right? So you guys need to understand that the person's weight is down, the reaction is here. And if the lift is moving at constant speed, both are same. But if the lift is accelerating here, this means the resultant force is here, which means that then naturally your reaction will be smaller. But if the acceleration is up, then reaction is going to be bigger and weight is going to be smaller in the reality, right? So it says it's going upwards. Well, I think it's going downwards. So let's check if it makes sense. Motion at constant speed, it is not possible. If it is going downwards and it is slowing down means acceleration is upwards. So reaction should be bigger, not smaller. So that's also wrong. Then we can check upwards and upwards. So at constant speed is not possible. For upwards and slowing down. If it is going upwards and if it slows down, to slow it down, you need to accelerate it downwards or decelerate it. So it means the weight is the same, but the reaction will be smaller than the weight, which means that bathroom scale, this should be correct. Right? Now, please let me know if you do not understand this. Now, the diagram shows the graph of various quantities plotted against time for an object dropped from stationary balloon high in the atmosphere. Right. Which statement could be correct? The graph 1 is accelerating against time. Graph 1 is acceleration against time, and 3 the resultant force against time. But the graph shows vector quantities. Okay. Right. So graph 1 is acceleration, and then resultant force and acceleration are directly proportional. They should not be different graphs. So that's wrong. That's wrong. Graph 1 is acceleration against time, and graph 4 is resultant force against time. That's also wrong. Acceleration should and resultant force should go along. Graph 3 is acceleration against time. Graph 1 is the velocity against time. This is acceleration This is velocity. So basically, if it was velocity time graph, and as you can see, acceleration is decreasing because the tangents, and here the acceleration is also decreases. This should be the correct answer. But let's check 3 as well. Graph 3 is acceleration. In graph 2 is velocity time. That's wrong. Velocity is increasing. It shows constant acceleration. It does not. So that's wrong. So now let's go. Somebody actually asked me this too, like how to convert these. So you can go back to notes, check it out too. Which statement describes the motion P and Q immediately after collision? This said P and Q particle traveling at speed v.
So what was the answer for the last one?
It was C.
Yeah, I didn't get this one. Could you explain, please?
Okay. In why is it C? Because if this was velocity time graph, right? So I've told you that you make a tangent here, so it's almost vertical, and then you make a tangent at the, it is almost horizontal. So acceleration is reducing, right? Because
Yes, sir.
gradient is reducing. So graph 3 it says is acceleration. Graph 3 shows a reducing curve, so it has to be acceleration. That's why it is correct. See?
Oh,
It's going
okay.
down. If the arrow goes down, it means y-axis is reducing. Okay.
Okay, sir.
All right. In this one, it says about to collide with a stationary particle, right? So it's U1 is V, U2 is 0. Same mass, perfectly elastic. Okay, which describe the motion immediately. Now, if this is perfectly elastic, so you know that the only way to check this is one way. I told you U1 plus V1 equals to U2 plus V2. If these two conditions stay the same, then it will be fine. So the first condition is U1 is V and U2 is 0, and then you go to check what happens. P and Q both travel in the same direction as half-V. So let's take this as positive, let's take this as negative. So half-V plus half-V. This is not correct because it does not show you the right, it should, if it is elastic, then it should show you the right equation. This is 0, then again, U1 was V, and this was 0, now check. P comes to rest, it means it was 0 afterwards, and Q requires speed V. This could be right, but I told you never ever, fix something, check everything. There could be multiple right answers. Now, P rebounds with half speed. Rebound means minus half P. And Q requires speeds half P. You see? Now, V minus half P is half P plus. This could also be the correct answer. Never ever stop at one answer. Check all of them. Then the last one, it says P rebounds with speed V, like minus V. And then Q remains stationary. 0, 0, this could also be correct. Okay, fine. Now, when a situation comes when there are multiple correct answers, then you check momentum as well. Okay, so what you do? The equation m1 u1 plus m2 u2 plus equals to m1 v1 plus m2 v2 should also conform to our rules. Okay, so this was m, this was v, this was m, and this was 0. Afterwards, in this part, P comes to rest, and that requires V. So what you get? MV equals to MV. I know for sure that this is the right answer. Now, how are others wrong? So you can check again. MV plus M0, and for this one, I'm just doing it for your own sake. Rebounds, so this rebounds with minus half P, and that gains half P. So you see now it gives me mv equals to 0. So that's not correct. Momentum doesn't conserve. Momentum should always conserve. Then this is, let's check, mv plus 0. And now let's do it. The last one. Rebounds with speed v, so m minus v, and this stays 0. So now the answer is mv equals to minus mv. This is also not correct. So that's how I chose v. Okay. Now you don't have, once the momentum conserves, right? So you don't have to go forward. I just did it for your understanding. It could be multiple instances. Now, a particle uniform field. So we're now going to do this. Maybe move forward. What are the resultant force acting on the rod resultant moment? Okay. The uniform rod of weight 20 of 2. So basically we're saying that this is like 2 and there is at the center there has to be a weight of 20. Resultant force. The resultant force should be, I think it should be 0. The reason behind this is because upward forces minus downward forces add up 0. Now these are wrong. Now let's check moment. So, well, resultant moment. Interesting. There is 20 and we need to fix some pivot, you know. If I fix this as my pivot for just a reason. So this is going clockwise. This is going anti-clockwise. So I would do clockwise equals to anti-clockwise. The other one does not have any moment because I've taken pivot here. You can take pivot anywhere, by the way. So clockwise moment is 20 times 1. 5 times 2. So this is 20. This is 10. So 20 minus 10 is the result of 10. So it has to be this. A should be the correct answer. Do you guys understand? You could take pivot here, 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 anywhere, as long as you know the distance between that point, right? Now, it would give you the same answer, by the way. 3 co-planar forces. Which diagram shows direction of forces such that the box could be clipping? In these type of questions, you should remember this is only way when all the line of action somehow meet at one point. At A, they don't meet. So you have to use a ruler, by the way, for this. Here they all meet, so it has to be B. But you can check the other ones as well. Nope. Nope. So it has to be. So make sure you do it with the ruler and extend the lines forward and backward. Where all of them meet, it means that that object is in equilibrium, others are not. A cylinder contains a volume of this and pressure of this. 400 joules of work done on this gas with its pressure remaining constant throughout. What is the final volume? So we know work done is pressure times change in volume. Work done is 400. Pressure is 1.0 times 10 raised to 5. And we got to find change in volume. So 400 divided by 10 raised to power 5 is 0.004 centimeter cube as change in volume. So suppose that pressure, if something is like contains work is done on the gas. Okay. So final minus initial is what we want to do. X minus 0.01. So you take it there, it adds up, and it should be, no, it should not add up somehow. That's not right. If the work is done on the gas, it means it is being pushed inside. So it will become, yeah. So then final will be smaller. So you always have to do bigger minus smaller, by the way. And now this will be 0.012 minus 0.004. So this will be it. Now, I just want to tell you, please remember this. When it is written work on some gas, on, they've also highlighted it. On means that gas is compressed. And compression means that it is being, volume is reducing. And when work is by gas, work done is by gas, so gas expands. So please do remember that volume increases. Now the ball thrown vertically upwards from the surface, which statement describes the energy of ball rises through air? Total energy cannot increase. So that's absolutely wrong. Kinetic energy of the ball increases as the gravitation decreases. That's wrong. Because gravitation increasing. It's upward from the surface. The kinetic energy ball decreases, gravitation increases. That is correct. The kinetic energy ball decreases, gravitation. That's wrong. One has to increase. The sledge of mass 50 sits on the snowy surface. It is pulled horizontally for 10 meters against a friction force. Then it is pulled horizontally across ice for this. There is no friction between ice and sledge. It is lifted up vertically by one and finally carried back constant speed where it started. Okay. Okay. It is lifted up vertically by one and finally carried back constant speed. During which stage its journey most work done on the sledge? Of course, when most work done is right. So if let's suppose this is the sledge and you're applying like 1000 newtons, right? And there is 200 newtons initially. So the force that naturally, the total force is going to be 800. And then whatever you move, the distance you move, let's say it goes like 10 meters. So 800 into 10 would be 8,000, right? In snow, however, you're applying the same force 1000 and the work will be 1000 times 10. So that is 10,000 joules. So definitely snow is one of our answer. And then when it is lifted up, if it is lifted up, let's suppose you apply the same force of 1000, you lifted 1 meter, so it is going to be 1000 joules. And there is nothing else. So I believe that it should be being pulled 10 meters across snowy surface because, no, wait. If ice, you have to apply 1000, let me think. And plus, in this, you need to overcome the friction as well. So you need to apply like 200 more. It should not be 800, it should be 1200. 1200 into 10 is 12,000. So it means you also pulling it and doing work should be the most, right? So it should be the most work done is at when it is pulled against friction force plus its own. That is snowy surface. So it has to be deep. Okay. Please let me know.
I don't know this. Where did you get the 1000 from?
I just assumed a value.
Okay.
I just assumed a value that I'm applying this much force, like my pulling force is this, right? For the sledge to move at certain speed. Now, if there is some force, also there that is, opposing me, so I have to apply more force to go at the same speed. Don't you think so, Anusha?
Yeah.
So it means that force adds up 1200. If there's no friction, that I only need to apply this force, which means less work. And if there is just less distance, then I have to do less work altogether, right? Do you understand?
Yeah, I do.
So this means that the most work is done when I'm going through this now. Got it?
Yes.
Okay. Now, the distance between various points on the diagram indicates the object weighs 20. Where is the object? What object? An object is moved in a vertical plane. Oh, okay. How much gravitational potential energy does the object gain by moving x to z? X to z? We just need to find, this is the vertical. So it has weight. So mgh. mg is 20, h is 3. Has to be 60 joules only. This is pretty simple. A car travels at constant speed, 25, up the slope. The wheels driven by engine exert forward force. The total force due to air resistance. The weight has the component of 900. At which rate the thermal energy is dissipated. Okay. So forward force is this. And this weight does not really constitute to, losing energy. I think friction does. So we need to this force times the velocity. This will give us power, force and velocity. So still let me check. Okay, so this has to be 5250. This is work done against friction, right? So C should be the right answer then. Okay, so this.
Can you not subtract it?
No, because if you look at it, the forward force of the car is 3000. It has nothing to do with heat dissipation. Only friction can dissipate heat. The weights component is downward 900, and this is 2100. So which force is responsible to oppose the motion? Only this force, and also this force. But this force is the friction which is causing heat. The downward weight, like you're sitting right now on a chair, right? Anusha, your weight is down. So is your weight causing heat? Tell me.
Yes. No, I don't know.
No,
Okay.
no, it is not, because weight is not, a force that rubs against a surface. So only friction does it, and that's why.
Okay.
Pretty.
Okay. Yeah.
That's why we only take this.
Got it.
Now, the composite rod is made by attaching.
So I don't get this question. Could you please re-explain?
Yes. So I was saying that your weight, there are three things given: engine force, weight, and friction. Engine force is coming from engine. It is not producing any heat. Do you understand?
Yes, sir.
Your weight is just the gravitational pull of Earth. Is it producing heat?
No.
So it says which force, at which rate thermal energy, thermal means heat. Only friction can do that. So we're going to pick the force that is equal to friction and use it to find power, which is force times velocity. All right?
Oh, okay.
All right, now. The rods have the same cross-sectional area. Each rod is one length and Young modulus. Now, whenever which is the greatest tensile strength? What is the greatest tensile strength that can be applied to composite before it breaks? Okay, fine. Now, suppose we want to find the maximum stress. Maximum stress is, what could be the maximum stress? That would be basically the stress on plastic plus the stress on nylon. Right. If we apply this and they reach like the maximum stress of their own, it is going to break, right? So let's focus on that right now. So we want to find this, and the maximum stress is the force per unit area. Right. Okay. Well, no, this is not happening. We don't have the force, unfortunately. We don't have the area. So we can't do this. Okay, not like this at least. It says the composite rod will break when its total extension reaches this. Okay, now this is the clue. So let's say we have the total extension, and the extension in plastic and extension in nylon will, when it reaches 3, it will break. Fine. So we know that E is equal to FL over AX, and X is going to be FL over AE. So I'm going to replace it. So I'm going to write FL over AE plus FL over AE. I'm considering that this F and this F is just the same, right? Now check it out. For the first one, force is the same. The length is 1. So I'm just putting it. It says the rods have the same cross-sectional area, so A, and Young's modulus of plastic is 40 GPa, 40 gigapascals. So I'm going to write 10 raised to power. Giga is 9, by the way. And then for the second one, the force is the same. The length is 1. The area is the same, but it is 2 gigapascal. Like this, right? And the total extension it has given us 3 millimeters, which is equivalent to 3 into 10 raised to minus 3. Just like that, right? Now I'm going to take my calculator out. I'm going to try. Well, what to try? There's nothing to try, actually. So I'm going to try 3.0 times 10 raised to 3. This is equivalent to 1 upon 40 times 10 raised to 9. Okay, if I take force and A common, so if I take this force over area common, so what you get? 1 upon 40 into 10 raised to 1 upon 40 10 raised to 9 plus 1 upon 2 times 10 raised to 9, like this, you see. Now I can find just force over area, which is the stress maximum we want to find. So I need to divide all of this with 3. Okay, check this. 1 over 40 times 10 raised to 9 plus 1 over 2 times 10 raised to power 9, like this. Okay. Once you do that, then 3.0 times 10 raised to power minus 3, and I could divide the answer. So I'm getting 5.7. 1, 2, 3, 4, 5, 6. 6 Newton per meter square. And the answer is B. Okay, please let me know if you do not understand this. So these questions are quite, tricky, I know, but you got to find the clue that is there. So I made a clue, made an equation, and did it. Thankfully, we have more time for paper 1. This is a harder paper anyway. So what is the estimate of work done stretching? So, all right, we need to find half. So if I make a half, right, like this, so I'll just add some of it extra. So half times 100 times 2 times 10 raised to power minus 3. This is 0.1. Now it can't be this. Why? Because of course we didn't take this much area. It can't be this because it's too big. So it has to be somewhere which is much bigger than this. So that has to be C, right? Just like that, the estimated. The wave of frequency 15 travels at 24 through a medium. What is the phase difference between 2 points 2 meters apart? So first of all, I'm going to find the wavelengths. V is equal to f lambda. Speed is 24. The frequency is 15 and lambda is lambda. So 24 divided by 15 would be 1.6. Right. Now this is the lambda. Now what I'm going to do is, it says what is the phase difference. If 1 lambda is equal to 360 degrees, right, then 2.0 is going to be how much? I'm going to cross multiply this. So it is going to be 360. You could do the same thing with time period, by the way. 360 times 2 divided by 1.6. It is 4 what? Yeah. So it is about 450. 450 means that actually it is 90 degrees ahead, right? So 90 degree means a quarter, because 90 is quarter. They are out of phase by a quarter cycle. That has to be the correct answer for sure. Right, so you do it like this. Now, which road describes the longitudinal wave and medium through which it can travel? Longitudinal wave is always parallel, and the medium it can travel is air. In vacuum, longitudinal cannot move, by the way. Now, the sound wave.
So sound is the only longitudinal wave, right?
And slinky string. And
oh, okay.
Earthquake.
Oh, okay.
Okay, time basis per division, what is the frequency? So you see that there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 divisions, and in 8 divisions, they're like 1, 2, and no, the other wave is not the same. So let's take the number of waves that are in 2. 1, 2, 3, 4, 5, 6. So there's 6 divisions for 2 waves, which means 1 wave has to be equal to 3 divisions, right? Now what I'm going to do is I'm going to use time period equals to time base, which is 50 milliseconds per division, multiplied by 3 divisions. You have to do 1 wave. So this is 3 into 5 is 1.5 milliseconds. So frequency will be 1 upon time period, 1 upon 1.5 times 10 raised to minus 3. So it has to be 666. What is this number? 670, I believe. All right. Now, please do let me know wherever you get stuck. An observer is situated at top of the tower hall. The airplane emitting a frequency of this approaches the observer. Okay. So the moment I see approach, then I got to use Fs times V over V minus Vs. So frequency of airplane emitting a frequency 1000. And the speed of air is 330. 330 minus 165. What is the frequency received? Okay. 1000 minus 330 divided by. No.
Why are you subtracting it?
So, yeah.
Oh my God. Sorry. My bad. मुझे अब रोजा लग रहा है actually. 330 minus 165. It has to be 2000 then. D. Right. That's a lot of difference. It's cool. Okay. So then,
Sir,
yes.
I was confused about this question because how can it be 2000? How can it be greater than the original frequency when it's still approaching?
Doppler's effect.
Oh, so should it be less?
No, it would only be less if it is moving away. If it's moving towards an observer, it will be more than the original.
Not all that.
Okay, what is the order of magnitude wavelength microwave? So microwaves fall under somewhere here. Wavelengths, yeah, somewhere here. And the X-rays fall between somewhere here. So that has to be the right answer. I mean, this is all rote learning. Please do it. Now, a musical instrument. Oh, this is my favorite question. So first of all, it says with a mouthpiece in one end and the other end is open and flared. So this is one end, one open, one closed. The moment you see this, you should remember it is a frequency question. So frequency equation for one end open, one end closed is this, and where n is equal to 1, 3, 5, 7. So first of all, it says the minimum frequency is 92. So we're going to write 92. V is V. Minimum n is 1 and 4L. It means 92 is equivalent to V upon 4L. Now, it says which are the different frequencies. Now, next one will be frequency equals to V over 4L and n is going to be 3. So we already know this is 92. So 92 times 3 is 276, right? I think. Then the next is going to be 92 times 5. 92 times 460. So that has to be the answer. Very simple. Now, then it says water wave passes through a gap between two barriers. What is the name of phenomena? That has to be diffraction. No doubt in that. C. Then 28. 28 says the table shows 4 possible combination of values. Okay. Which combination result in visible fringes being observed? Oh. Okay. That could be something. Acha, this question, I tell you something. What I'm going to tell you is that basically the most visible fringes appear when lambda is approximately equal to the slit separation. Yani K. Now we're going to check. This is 200 nanometer. 200 nanometer basically. Okay, right. So if I change this into nanometer as well, so what will it be? 0.1 millimeter is like 0.1 times 10 raised to minus 3, right? Meters. And nano means if I want to change it to nano, I got to multiply it by 10 raised to power somewhat. Yeah. Okay. I got to multiply it with somewhat like 10 raised to minus 9, right? So I need to increase by 6 times. So 6 tens. This will be huge. Like this will be like 1, 2, 3, 4, 5, 6. Okay. So this will be this much nanometer. And that is going to be 200. So there's a huge difference. A cannot be correct. Now here it is, this is even bigger difference. So this cannot be correct. Now let's check this one. 600 nanometer and about 0.01. Okay, this will be 0.1 times 10 raised to minus 3. This will be 600 times 10 raised to minus 9, which is basically 6 into 10 raised to power minus 7. Okay, so that's still a big difference, but smaller than this one. And here it will be 600 or 6.0 times 10 raised to minus 7. This will be 1.0 times 10 raised to minus 1. This is a huge difference again. So the most, like the closest one that I can feel is this one. See, this column is irrelevant. Distance between screen doesn't matter. So it has to be C for all facts. because it should be, wavelength should be closer to it, and this is the only part that makes that. Then it
Sir?
says yes.
If I want to calculate the fringe spacing, so should it be greater or like less for it to be visible?
It doesn't matter. It doesn't matter, but because it is ax equals to lambda d, right? This should be like closer to each other, right? So I think that if you have you calculated this, interesting. It should be greater. It should be smaller in these cases. Well, it won't really matter, really. You have to go through this. Basically, it's not a question about this. It's a question about diffraction. Anusha, is it clear?
Yeah, okay.
So in that case, the difference between these two should be very, very small, because there's a d that is different as well. So basically, it doesn't really make any, I say contribution to our assessment. That's why you should
Okay,
not.
so I shouldn't be calculating the fringe spacing.
You should be only looking at how different these are. The
Okay.
closest, if they're closest to each other, that should be the right answer. That's why I calculated. Okay.
Okay.
Now, the angle between the two second orders. So the second order is phi, which expression gives the spacing of lines, gives the spacing of lines on diffraction rating. That is, he's talking about d, right? So d sine theta equals to n lambda. D sine of phi by 2, because that's how it is. And this is 2, and this is lambda, right? So D would be 2 and sine phi by 2. So that has to be this one then. Pretty simple. By the way, angle wala 2 does not come out. Don't make that mistake, okay? Very popular mistake. So you don't have to do it anymore. Negatively charged, you don't have to do it anymore. Electrons, you don't have to do anymore. Okay, this one. A current from the battery is 3 ampere. Fine. What is the value of ratio of power dissipated in resistor? 3, 6, and 2. Right. First of all, you should understand this current basically goes through this for sure. Okay. So we are going to use power is equal to I square R. I square R. Okay. So here I is 3 square, R is 2. So 3 square is 9, 9 into 2 is 18 watt. Now we got to find this. Now, if you want to do it really quickly, you want to know how much current goes here, how much current goes here. So I just want to tell you one method of this, right? So first of all, you will make a sort of a ratio, okay? So suppose you say the total current is this, right? Now, remember, resistance and current are inversely proportional. So what you do this time, suppose you want to find I1, the current here, and let's call this I2, right? You want to find I1. So for finding I1, you would put the other resistor 12 on top. And then you're going to add both of them, right? And then multiply the total current, right? So what you do, 12 divided by 18, 12 divided by 18, multiply by 3. This is 2 ampere. So here it will be 2 ampere. If this was a direct proportion, we'll just keep this. Now you'd be surprised, how did I know this? Well, this is strange, right? But don't worry. Now, if you do not understand how I did it like in second, what you can do is, you can find the total voltage here. How do we do this first? So you can find the total resistance. So total resistance will be 1 upon 6 plus 1 upon 12 equals to 1 upon R. This will be 12, this will be 2, this will be 1. So 1 upon R will be 3 over 12. So R will be 4. So total resistance is 4. Then you use V is equal to IR to find the voltage across this hole. 3 is this, the total resistance is this, so 3 is 12 volts. So this is 12 volts. 12 gets this, 12 gets this. So then here the current will be V is equal to IR. Again, this will be 12. I want to find, this is 6, so I is still 2. So if you want to go through all this or just this, it's up to you. So inverse ratio means that you have to put the other resistor on top. In direct ratio, you have to put the resistor you're finding on top. Now, so 2 ampere, okay, so 2 ampere. Now what you will do is power equals to I square R. This will be 2 square and that is 6. 2 square is 4 times 6 is 4, 6 is 24. So 24 divided by 18. So it has to be, what is this? 4 by 3. Is it clear, everybody? Good. Now, a
No, sir,
manufacturer.
no.
No?
Nope.
Okay, what do you want to ask? Which method?
Could you just explain this again, like from the start, because I didn't get it.
Okay, it means you still haven't seen the recording. Have you? No money.
Which one, sir?
The electricity one. DC circuit.
I took it with you, sir.
Because this is series and parallel. This should not be like this. Anyway, so first I will do ratio method. Okay. Suppose you want to find current. Let's call current in this I1. Let's call this I2. So the 3 ampere is going to split, right? Agreed?
Yes.
Also, I know that resistance is inversely proportional to current. Do you understand?
Okay.
You get it, right?
Yeah.
So now what you do, you put I1, if you want to put I1, you take this resistor, put it on top because inverse proportion, and then add both of them. That is going to be 12 plus 6, right? Is it clear? And then multiply by total currents. This will give you the answer to this one method. Okay?
Okay.
The other method. So I'm going to show you 3 methods now.
But we got here like 2 amps. Answer, what is the answer? 2, right?
2 in this.
2 in that only, okay.
Okay, now let's suppose I say I1 is the current in 6 ohms. Okay. Now,
Yes, sir.
then I want to find what is the total resistance here. The total resistance here was 4. How did I calculate? 1 upon R equals to 1 upon 12 plus 1 upon 6. So 1 plus 2. And R was 4. Okay. And 3 ampere is going in this hole. So this is 4 ohms. Do you understand what I'm doing?
Yes, sir.
Now, please understand. In inverse ratio, you don't cross multiply, you direct multiply. So I1 will be multiplied by 6 and 3 will be multiplied by 4. So 3 4s are 12 and 12 divided by 6 is 2. Do you understand? This could also be done.
All right.
All right. One longer method is that once you know that the whole, this is 4, so you find the voltage. So now I'm using equations. So voltage is IR. I want to find the total voltage given to these. The total current is 3. The total resistance is 4. So voltage is 12 volts, right?
Yes.
So please understand, this gets 12 volts, this gets 12 volts. In parallel, the voltage is same, right? Now I use V is equal to IR again. I know that I want to find I, the voltage is 12 and the resistance is 6. So the current is no matter what you do. Do you
Yes,
understand now?
anyway, it's 2. Yeah.
So then you use power is equal to I square R, power is equal to I square R, divide them and you get this answer, just like I did.
All right. Okay. Okay.
So you got to practice this. Okay, please do. The manufacturer recommends that longer the extension cord you use with an electric drill, the bigger the cross-sectional area of cord should be. What is the reason of recommendation? Because resistance is inversely proportional to area. That's why. Let's find. Resistance is inversely proportional to both length. That's wrong. Resistance is inversely proportional to length. That's wrong. Resistance is proportional to length, and that's wrong. Resistance is proportional to length and inversely proportional to cross-sectional area. That is correct. Okay, now we have, okay. Battery 1 is electromotive force 12, internal resistance 3. Battery 2 has electromotive 9 and internal resistance 1. What is the EMF internal resistance of single battery that has the same effect as combination? If we combine these two batteries, right, you might see that this battery is connected, like positive is here and its positive is on the other side. So they're connected opposite to each other. So if you say this is positive, this has to be negative then. So 12 minus 9 is 3. So answer would be A and B should be like 3 only, first of all. Then internal resistance, no matter which direction it is, the resistance always adds up, which means that 0.1 plus 0.3 is 0.4. That's VP. Okay. Now, the diagram shows the circuit. What is the reading on the voltmeter?
Sir, could you explain the upper one again, please?
Yes. So, man, if you see the batteries, they are ulti to each other. Battery should be like this, right? Don't you think so? Positive, then negative, then positive. Positive
sir.
and negative connected. Here, this is negative and this is negative. Both are like connected in the opposite direction. Okay. So it means you
Yes,
got
sir.
to subtract them.
Okay, sir, got it. Thank you.
And then resistance always adds up in series. So that's fine. Now, the diagram shows what is the reading on voltmeter. Now, these are two resistors. Now, internal resistance EMF is equal to I times R plus I times R. You know this, right? Now, he wants you to find this voltage, but we don't know the current. So first of all, we use this. I, what is this? 2 plus R is 0.1. So 6 and 2.1. 6 divided by 2.1. So the current is 2.86, okay, ampere. Fine. Now V equals to IR. What do I need? I have the current in the circuit. I want to find the voltage across this, so the resistance is 2. So that is 5.72. Okay, that's B. All right. So this is should be the answer. Okay. Now, 37. In a circuit shown, the cell has a negligible internal resistance. Which diagram shows a potential divider circuit across the lamp? Okay, so potential divider circuit, I told you, it is a series circuit, first of all, and it is always connected like series circuit and with a voltmeter or something like that, right? So this is a parallel circuit, so this is absolutely wrong. This is a wrong circuit because the current just will go from here to here. It will never reach here, so this is wrong. And this circuit is a parallel series circuit in the sense that the current will go here and then it will go halfway. Or if it was connected here, it will go full length. So this is the correct way to make it. This is a parallel circuit. That's wrong. Now, two alpha particles, same kinetic energy moving. Which diagram shows the paths? The one that is closer would deflect more. One is less close would deflect less. So this makes more sense. No, yeah. This makes more sense. D. This doesn't make sense to me. This is not at all. These are attractions. This doesn't make sense because the closest is not deflecting, the farthest is deflecting more. So it has to be D. The equation is this. What are the particles P and Q? Okay. If this is smaller than this, so it should be 0 plus 1. And if this is 0 and plus 1 to, balance this out, this should be 0 and 0. This is positron and this is electron neutrino. Neutrino and beta positive. This is very simple. Right? Okay. Now, which row gives the correct type of quark composition for the named particle? Neutron is definitely hadron. It is not up, up, down. Neutron is lepton. That is wrong. Proton is hadron. It is up, up, down. That is correct. Proton is not lepton. Okay. Finish. You guys have any questions? Please let me know. Okay. Now I want to ask you one question. Let me stop the recording first.